In this video, we are going to do these two questions from the chapter application of derivative based on maxima minima. So let's begin with the first one. It says find the point on the curve y square is equal to 4x, which is nearest to the point 2 minus 8. So let's say if I have a curve like this and its equation is what? Y square is equal to 4x, and let's say there be a point somewhere and its coordinate is given as how much? This is 2 minus 8. Now they're asking for a curve. There is a point on the curve though. We have to locate a point on the curve, like the point has to be on the curve such that it is minimum distance from this. That means this distance, whatever is the distance, we have to minimize it. Let's say I take this distance as d and the point over here as x comma y, the general point over here. So this is the point we have to locate. Now, the first thing that we will do here is, let's say first I write down the equation over here, and then we can straight away find the distance. That's better. Distance is what? The formula is x2 minus x1 whole square. So is x minus 2 whole square plus y minus 8, that is plus 8 whole square. And later I can write this as d square only, so as to minimize. So this wasn't needed, in fact. Now next what we are going to do is to replace this d square with z, right? So you know that as d square will minimize, z will also minimize. So we'll do expansion first. So this is z is equal to applying a plus b whole square, a square minus 2 times ab, that is 4x, plus b square, that is 4. On the other side it is y square plus 16y plus 64. So z is equal to, now I'm going to do substitution. What I'll do from here, we'll get substitute x, and x is what? Y square over 4. So I'll be substituting this x here. One x I can see here, and there is another x. This x will be substituted. Now, so substituting x square, so x square will be square of this. That means this is y square, and what is square of 4? That is y square whole square, that is y raised to the power 4, and 4 square is 16, minus 4 times x, replacing x with what? Y square over 4. And then I'll write y square first, plus y square plus 16y, and these two will be added to give you 68. That's 68. Now we can see that here 4 and 4 get cancelled. So this is minus y square and plus y square also get cancelled. So we can differentiate in this step only. So dz by dy, right? We're differentiating with respect to y. So this is 4y raised to the power 3 over 16 and plus 16 only. This becomes 0. Now what we can next, to find its double derivative, I can reduce it first. So this is d square z by dy square. Second order derivative should result to give you what? 3y square over 4. Well, y square is always positive. So from here we can say that this is second order derivative is greater than 0, right? Now, once we have obtained this, next is to equate dy by dx with 0. That means for maxima or minima, we equate dy by dx with 0. Equating this with 0, what we are getting? This is y cube over 4 on transposing 16 to the other side. So this implies y cube is equal to minus 64. So that results to give you y as minus 4. Now, once we have obtained y as minus 4, so what can x be, right? So what we can see, x can be from here, right? We got y as minus 4, so x can be what? This is 4 square is 16, 16 over 4. right? Y is minus 4, so this is going to be minus 4 square, that is 16 over 4, that is 4. So x comes out to be 4. Now, right, so we got the required point, and the required point is x4 and y minus 4, right, which is nearest to this. Very similar to the previous question. Here too also we are given a curve. Let's say if I make a curve over here and there being a point over here, its coordinate is given as 1 minus 4, and we have to find out the shortest distance from this curve. The equation of the curve is given as what? This time it is y square is equal to 2x. Now let's say if I take this point as P, coordinate being xy, and this being the distance. So what I can write d square as what? Whole under root x minus 1 whole square plus this is what? Y minus minus 4 is y plus 4 whole square. Oh, why did I give under root? Now we'll do substitution. That is, first of all, I'm going to replace z squared with d squared with z. Doing expansion over here by a minus b whole square, a square minus 2 times a b plus b square. The other side we have y square plus 8y plus 16. Right. And then next we are going to replace x over here, right? X is actually y square by 2. So replacing this x over here, this is x square, so it should be y raised to the power 4, and 2 square is 4 minus 2 times x, and x is what? Y square over 2. This to get cancelled. Plus I'm writing this y square first, and then 8y plus 1 plus 16 is what? 17. Like the previous question, here 2 y square get cancelled. And what we get z as y raised to the power 4 over 4 plus 8y plus 17. So we'll do differentiation. That is the first. We'll differentiate with respect to z, sorry, with respect to y. So it's going to be what? 4y raised to the power 3, that divided by 4, right? We have a 4 over here. This 4 get cancelled, and then this is 8 only. This becomes 0. Next, I'm going to find its double derivative. So differentiating it once again with respect to y, this is d square z over dy square is equal to what? 3y square, right? Which is greater than equal to 0. As you know, square of a number is greater than 0. That multiplied by 3 will be greater than 0. Therefore, we'll say this is, what's that? Minima. Now, next is to equate dy by dx with 0. So equating this y cube over is nothing. Y cube plus 8 with 0 implies what? Y cube is equal to minus 8. So y has to be minus 2. We got one value, or not plus minus 8. So we got y as minus 2, and I'm going to place y here. I'm going to place y over here. So what we get x has minus 2 square is what? 4. 4 divided by 2 is 2. So the required point is what? 2 minus 2. That way we can say this is the required point, which is minimum, which is at the nearest to this point. Further, you should write over here the statement that two statement you have to write down. Number one, for maxima or minima, dy by dx has to be 0. And one statement you should write over here that since this is greater than 0, hence maxima at x is equal to y is equal to minus 2.